Hey everyone, welcome back to the channel. Today we are going to build a simple LED blink project using Raspberry Pi Pico, and we are going to write the code in C. This is the best beginner project to get started with embedded system. So let's dive in. So first we need to understand that what is Pico. Before we write any code, let me quickly tell you what the Raspberry Pi Pico is. It's a microcontroller board, not a full computer like a Raspberry Pi. It is designed to control hardware directly, so it runs your code, control pins, and that's it. Simple and powerful. We are going to simulate this on a free website. You can see Wokwi, and that's why you can go to this website and create your own projects. So you don't need to buy any hardware to follow along. Just open your browser. Let's let's look at internal LEDs. So today you are seeing that we are going to use this 25, and this 25 represents this internal LED you can see at my mouse click. This is a very small LED, but it's on your board. So we are going to control this LED from our code. So let's look at the code, how it works. So basically you need to open a new project and you will come here like main.c. Here you need to write your code. And then you need to create a CMake, basically which you are importing everything from like the Pico SDK, and you are linking the Pico Blink to main.c. But this is pretty simple. You can get the code here, just pause the video and just copy the code. And then the main.c. The diagram.json, you can copy the initial version if you want to, otherwise when you add, it will automatically update the diagram.json as well. So let's go line by line. What does this line means? The first line includes the Pico standard library. Think of it like importing a toolbox. It gives you all the feature we need to control the hardware, like setting up the pins and sleeping. Then we start with our code, which is int main, and this is the main entry point of our code. As I told you, the number 25 is on, so we are using pin number 25, and that is special because GP25 is connected directly to the onboard LED on the Pico board itself. You can see it physically on the board. This is a tiny green light and doesn't need any wiring. Then basically the next step is to initialize the LED pin, basically telling the Pico, hey, we are going to use this pin, get it ready. Now we are seeing basically the set the direction of GPIO out means we want to send a signal out from this pin. If we are reading it, if you're reading a button press, for example, we would use a GPIO in. So basically that's why it's out signal, not an in signal. But we are doing a button press, we would read it as an in signal. Now we are going into a while loop. Why? Because if you don't put a while loop, then it will turn into so fast that you won't be able to see. So what you are doing here inside the while loop is that we are running continuously and not stopping after one execution. One turns the pin high, that means send the voltage out, which turn the LED on. And basically 500 millisecond is the time in between it will blink. So it will turn on and it will turn off. So it will turn on and it will turn off. So this is how we are basically controlling. Now what we do is that we save our project and then we click here. So this is basically compiling. First it compiles. For me it's already compiled, and then you can see the small LED blinking. Good. We have achieved our first step. Now for the second step, what we are going to do is that we are going to move to external LED. So what we need to do for external LED? First we need to get a LED. So as you can see, LED comes with a long leg and a short leg. So this is your long leg and this is the short leg. Short leg is always going into ground and the long leg needs to be connected to voltage. You need to be very careful here. Why you need to be very careful is because any pin in the Pico gives out 3.3 volt. If you try to attach a LED directly to 3.3 volt, it would probably burn. So what we need, do you know the Ohm's law? If you don't remember it, it's a good time. It's a good time to again go to the Ohm's law and just see what it does. So basically we need to calculate the resistance it needs. So by a simple calculation, like we have a 3.3 volt in the pin, the LED uses about 2 volts, so the resistor needs to handle the remaining 1.3 volt. So we want around 10 milliamps of current, that is 0.01. So if you divide by the Ohm's law, we need approximately 130 ohms of resistance. So what we do is that we need a resistor. The resistance of this resistor should be 130, but we take 220 because when you go to the market, this would be the minimum you found. Right. So as we said, the shorter leg should go to the ground. To see where the ground is, you can just see, okay, we can connect to this ground, doesn't matter. So there are multiple ground in this pin, you can connect to any ground. So this pin, so this is the long leg, and first it should go to your resistor, and then the resistor should go to your power. Here we are connecting it to GP15 because as we said, we are going to power it from GP15. Now what we do is that we power it. We change the LED pin to GP15 because as we said, now we are going to use the GP15, and that's the only change actually you need to do in your code. There is nothing to change much. Now we save the code and we click on the simulation. So as you can see, now it is blinking. Now the internal LED is not blinking, the outer external LED is blinking. So now you have just built your first embedded circuit, both in software and hardware. We learned how GPIO pins works, how to control them with C, and why resistors are essential for protecting your components. If you found this useful, please hit the like button and subscribe for more embedded projects. Next time, we will see another good example of our embedded, so stay tuned.